If you'd like to compare a sample average to a theoretical value, but you can't use a parametric test because its assumptions are violated, you can often use the Wilcoxon signed rank test. It's more powerful than the sign test, but still makes very few assumptions about the data. In this video, I'll explain how it works. The Wilcoxon signed ranks test is seen as a non-parametric equivalent to the one-sample t-test. While the t-test compares the sample mean to a theoretical value, the signed ranks test compares the median to a theoretical value. The signed ranks test is non-parametric because it makes fewer assumptions than the t-test. Apart from the usual assumption of independence among samples, it only assumes that the population distribution is symmetric. Even though the mean and median are different population parameters, the question underlying the signed ranks and t-tests is the same. Are the observations in our sample coming from the assumed theoretical population? A large deviation from the expected mean, as well as the expected median, would provide similar evidence against the null hypothesis. Let me introduce the signed ranks test with an example. Imagine there's a confectioner in your town who takes things really serious. She doesn't make just delicious cakes and pastries. She also checks whether people really like them through a taste panel. You're among the lucky ones, and are already for a year a respected member of the confectioner's taste panel. Today's task for the taste panel is to decide which of two candidate pastries would be most suited to become the next pastry of the month. The one with orange mint and cream, or the other with strawberry chocolate and a crunchy crust. The procedure is simple. After tasting, each panel member assigns a score between 1 and 5 to express how much he or she likes that pastry. This is the result from the panel. As you see, some members clearly prefer the orange mint pastry, whereas others would go for the strawberry chocolate one. So, how to analyze this data? Let's start by translating the practical question of finding the nicest pastry into a statistical one, suitable for hypothesis testing. The question becomes, is the median of the differences between the pastry scores different from 0? It is a two-sided test. You cannot use a paired t-test because the data is ordinal. On the other hand, you could use a sign test, but then you would throw away some of the information. Clearly, a difference between a score of 1 versus 5 is bigger than between 4 and 5. The Wilcoxon signed ranks test is the right approach here. And it works by first taking the difference between each matched pair of observations. Next, you should rank the absolute value of these differences. If there are ties, you assign the average of the tied ranks. Then, you take the sum of those ranks where the difference was positive. And also note the number of values with non-zero differences, 6 in this case. The value that you've calculated is the Wilcoxon rank sum statistic, often abbreviated to W. The bigger the value of this statistic, the less likely that there is truly no difference between the average scores. By using a cumulative probability table or software, you can find the probability of encountering a given value W or higher with n non-zero observations. Because we are in this case interested in a two-sided test, this probability should be doubled. The pastry tasting example has illustrated the signed ranks test for a case with paired data. But it can equally well be applied to a situation with a single sample where you compare scores to a theoretical median. You are then testing whether the observed median and scores are different from what's expected. After replacing the values in this column with the theoretical median, all the calculations are the same. Without any changes to the method, the signed ranks test can also be applied to numerical data. If you have paired numerical data, you would subtract the values per case and then proceed as in the previous example by ranking the differences. And with a single sample of numerical data, the values would be compared with the theoretical median. The power of the signed ranks test is quite high, almost approaching that of a one-sample t-test. A major strength of the signed ranks test in comparison to the t-test is its robustness to outliers. But a minor weak point is that it does rely on the assumption that the population distribution is symmetric, one that is difficult to check, especially for small sample sizes. Let me summarize what I did explain in this video. The Wilcoxon signed ranks test uses data that is ordinal or numerical, and assumes that these are independent and identically distributed samples from a symmetric distribution. It tests the null hypothesis that the population median equals a theoretical value. The test statistic is calculated in 4 steps. First, the differences between the data and the theoretical median are calculated. Second, cases with a difference of 0 are removed. Third, the remaining data are ordered according to the absolute values of the differences. And fourth, the ranks for the positive differences are summed. This test statistic is compared to tabulated values. A special case occurs when you have paired data. In that case, the data values per pair are subtracted and then treated as a one-sample test against a median of 0.